Hey class, Mr. Husted here, and today we are starting chapter 2, which is going to be all about proofs and reasoning and all that kind of stuff, so it might be a little more difficult, so make sure you pay very close attention here as we go through these notes, and make sure you bring lots of questions with you to class. Today we're talking about inductive reasoning, okay? You're really going to have to work on your reasoning skills here as we work through this chapter. A couple of vocabulary words. A conjecture. A conjecture is an unproven statement that is based on observations. Okay, so when we notice a pattern in something, that is a conjecture. It's unproven, but we can observe it in what we see. Okay, inductive reasoning is used to find a pattern in specific cases. So we are going to use inductive reasoning to make a conjecture. Okay, and then the last part down here, a counterexample, a specific case for which the conjecture is false. We'll get into those here fairly soon. Okay, so let's just start with a visual pattern. When we look at these figures here, we want to be able to kind of describe how to sketch the fourth figure, and then also we're going to sketch the fourth figure. So if you look at these figures here, just look at what we see, okay? Got a circle, a line through it, and the upper half is shaded in. And in the next one, we go from having 2 parts to now having 4 parts. So we cut it in half again, and we've shaded again above the line, and now we're going to the left of that center line. Okay, so now again, with third circle, we went from having 4 parts to having 1, 2, 3, 4, 5, 6 parts now. So we went here, here, and here. Therefore, now we colored above the line and to the left of that line. Okay, so now what do you think the fourth figure is going to look like? So if we draw a circle here, okay, for our figure number 4, in each figure we've increased the number of lines that we've drawn. So we had 1 in the first one, we had 2 in the second one, and we had 3 in the third. So in the fourth figure, we're going to draw 4 lines, and yeah, not very good drawing, okay? But remember, we've always colored in above the half and to the left of the last one. So the last one was right here, so we are probably going to be in this region right there. So let's color that side in right there, okay? So that's just using your inductive reasoning skills to look at a pattern, describe it, and also draw on the next one, okay? All right, take a look at example number 2. Describe the pattern in the numbers, and then write the next 3 numbers that you would see. So I like to do what I call the little loop-de-loop method, okay? And by that I mean, okay, make a little loop here and figure out what did we do from -7 to get to -21. Hopefully you realize that 21 is a multiple of 7, and it's a multiple 3 times, so we multiplied here by 3, and then let's see what we did here. Okay, -21 to 63, that again is multiplied by 3, and then again, if it happens 2 times, it's more than likely going to happen the third, and then we multiplied by 3. So our pattern is we multiply the previous number by 3, by a positive 3, that's why we keep the negative sign. So what are my next 3 terms in this pattern? Hopefully you have your calculator handy, and you simply are just going to take -189 times 3 to find that the next term in this pattern would be -567. And then you'll do it again, times 3, and get -1,701. And for our third and final term, we'll multiply again times 3 and get -5,103. So again, I like to call it the loop-de-loop method. You can call it whatever you want. Just make that little loop there, figure out what's being changed, make sure that it's continually doing the same thing each time, okay, and then apply that pattern down to the next 3 terms. Okay, so let's make a conjecture. Remember, a conjecture is what? A conjecture is an unproven statement just based on observations that we make. So we are going to make a conjecture. Given 5 collinear points, make a conjecture about the number of ways to connect different pairs of points. Okay, so 5 collinear points. So those are 5 points all on the same line. So let's just start with what happens if we have 1 point. if we have 1 point, how many ways can that point connect to other points on that line? And hopefully you're saying, well, it's only 1 point, we can't connect to any other points, so that would be 0. If we have a second point on that line, how many ways can we connect from point A to point B? And your answer should be only 1. Okay, what about if we throw in a third line here? Okay, so we would have a connection from here to here, from here to here, and also from here to there. So that was 1, 2, 3 different connections. Okay, so that's when we have 3 collinear points. So now if we do our fourth collinear point, I'm trying to differentiate my color here as best as I can. Okay, we'd have the connection from here to here, from here to here, here to here, so that's 3. From here to here, 4, here to here, 5. So we would have 5 plus from point 1 to point 3, which would also make 6. So there would be 6 ways to connect 4 points on that collinear line. Okay? Now what about the fifth collinear point? Now before we even do that, let's take a look at our numbers here at the bottom. Because maybe drawing those lines are getting a little hazy and trying to figure out how many is going each way. Is there any observation you can make about the number of connections? So let's take a look at the loop-de-loop. Okay, that's plus 1. Okay, from 1 to 3, we added 2. From 3 to 6, we added 3. And you can see a visible pattern in what we are adding. So to figure out how many we have here with 5 points, what do you think we're going to add? What comes after 3? It's going to be 4. So we're going to have 4 more connections on top of what we just did. And so therefore, our answer to this is going to be 10. So we are able to start off with drawing our pattern and then using our inductive reasoning skills to locate that pattern, and then just apply a conjecture to it by adding an extra 1 to it each time. Okay? Again, these are some difficult topics we are going to be discussing here, so you need to make sure that you understand what I just went through there, what it means to make a conjecture. How can I arrive at that conjecture? You may need to draw. Pictures, and if pictures help, great. This is going to be a great chapter for you to draw pictures. All right. Okay, let's take a look at number 4 here. All right. So numbers such as 3, 4, and 5 are called consecutive integers. We want to make and test a conjecture about the sum of any 3 consecutive integers. So let's just pick a few examples. Actually, first, let's talk about what this means. Sum means when you add all of them together. Okay, so we are going to add 3 consecutive integers and just see what we get. So let's do the first one, 3, 4, and 5. When you add those together, 3 plus 4 plus 5, you should get 12. Okay, I don't know if you may or may not see anything discernible about that just yet. Let's pick some other ones. Let's just do the simple one. Let's do 1, 2, 3. 1 plus 2 is 3. 3 plus 3 is 6. Okay, I'm maybe still not seeing anything yet. Let's try another one. Let's go with 6 plus 7 plus 8. 6 and 7 are 13. 13 and 8 are 21. What are you noticing about any of these things here? Do you notice any correlation between any of these numbers and the sum of them? Do you notice anything about them? Anything that maybe goes with one of the numbers? Like for example, 3 is a factor of 12. 4 is a factor of 12. 2 is a factor of 6. 3 is a factor of 6. In this one, 7 is only the factor that of 21 that is in this problem. So let's try just one more. Let's do 8 plus 9 plus 10. 8 plus 9 is 17. 17 plus 10 is 27. So again, I just want to go through and kind of highlight here. 3 and 4 are factors of 12. 2 and 3 are factors of 6. Only 7 is a factor of 21, and only 9 is a factor of 27. Do you see any correlation here? Notice which number is circled every time. The middle integer is always circled, right? And what do we notice about that middle integer? Hopefully we notice that, oh look, 4 times what equals 12? Oh, 4 times 3 equals 12. What's 2 times 3? It equals 6. What's 7 times 3? It equals 21. What's 9 times 3? It's 27. So a conjecture we can make about consecutive integers, the sum of any 3 consecutive integers, is that, and we're going to write it out, so the sum of 3 consecutive integers is 3 times the middle integer. Okay? And again, this is just a conjecture. This works for what we have observed. And that's fine. Hopefully you start to look at patterns like that and you try to find what do all these have in common. You may have to search sometimes to find what they do have in common, but hopefully overall you're able to see what we're working with here. Okay, and then the last one. Okay, a counterexample. Remember, a counterexample, if we come back up here, is a specific case for which the conjecture is false. So if we're looking at a student makes the following conjecture about the sum of 2 numbers, find a counterexample to disprove the student's conjecture. So the conjecture is the sum, again, the addition of any 2 numbers is always greater than the larger number. So something to that effect would be like 9 plus 10 is equal to 19. The sum, which is 19, is greater than the larger integer. Is there a way to disprove that? I'm going to tell you right now, when you're talking about addition and you're talking about always greater than, the easiest way to disprove something like this or a counterexample is always to use negatives. Okay, so pick any 2 negative numbers you want. Negative 12 plus negative 13. So negative 12 plus negative 13 is negative 25. And let's just revisit the conjecture here. The sum of any 2 numbers is always greater than the larger number. Is this greater than this? Now think back to negatives. When we're dealing with negatives, our ideas are kind of flipped. So negative 25 is actually smaller than negative 13. Or in this case, actually our greatest number is negative 12. But negative 25 is still smaller than that. So therefore, we have just disproved that conjecture. And so we found a counterexample, and we have proved that it is false. So I know that's a lot of information to take in from today. Using inductive reasoning, again, rewatch the video, bring lots of questions with you to class, because this chapter will get difficult, but I truly believe that you are going to be able to do it, and you're going to be able to do it well. So rewatch any parts that you need, and bring your questions with you to class, and we will see you then.